Today we're going to be taking a look at prime factorization. If you remember from some of the activities that we've done in class, a prime number is a number greater than 1 and has exactly 2 factors. And the only 2 factors would be 1 in itself. For example, 3 is a prime number because the only way that we can get 3 is 1 times 3. On a side note that I would like you to add in here, if a number is not prime, we also have something called a composite number. Right? So a composite number is a number with more than 2 factors. So, for example, the number 6 is composite because we can get 6 by taking 1 times 6 or 2 times 3. Now there is a special circumstance number, or actually 2 of them, and those numbers are 0 and 1 are neither. The other thing that we need to realize about prime numbers, and this is from the activity that we were doing in class, is that prime numbers are really the building blocks of all other numbers. So remember with the activity that we did when we were putting those blocks or those pieces together, we were looking at the fact that like 2 couldn't be built with any other numbers, so that would make it prime. Same thing with 3. But then when we got to 4, even though we can take 1 times 4, we could break it down further into its prime factors of 2 times 2. So you would build 4 using 2 2's, just like we would build 6 using a 2 and a 3. And that's really what prime factorization is. It's going to be taking those composite numbers and breaking it down into the pieces or the blocks that make it up. And there's going to be 2 different ways that we can really find prime factorization. So one of those is called the ladder or step model. If we're going to find the prime factorization of 600, we're going to start with 600 at the top of the ladder because that's the number that we're trying to break down. The thing that you have to be careful of with the ladder or step model is that when we pull out factors, we always want to pull out a prime factor. For example, I know 600 is even, so it's divisible by 2. So what I'm going to do is I'm going to put a 2 on the outside as the prime factor, and then the next step down is my answer from when I take 600 divided by 2. In this case, it would be 300. 300 again, even number, so I could divide by 2 again, making it 150. Now some people sometimes are like, oh, well, it ends in a 0, I could divide by 10, but we can't pull a 10 out because 10 isn't prime. So we always want to just pull out prime numbers. Once again, 150 is even. So I'm going to pull out another 2, and now I'm going to have 75. This time 75 isn't even, so I have to think of a different factor. I could go back and refer to that divisibility rules chart. I know for a fact that since it ends with a 5, I can divide it by 5. So 75 divided by 5 leaves us with 15. And now I'm going to draw in, or divide, it ends with 5 again. So I'm going to divide by 5 again. And then I end up with a 3. In this case, if the steps were pre-drawn for us, if they hadn't been pre-drawn, I could keep adding steps as long as I had a number that was not prime after we're dividing out. The prime factorization becomes all of these numbers multiplied together. And I'll kind of show you that in a little bit. So what I'm going to do here though is I'm going to show you a different strategy. So a different strategy that we could use is we're still going to start with that 600 on top. We're going to use a tree diagram. The tree diagram was the one that I was most familiar with when I was in school, and I know a lot of students that like it because there's a little bit of flexibility with it because you don't have to always divide by a prime. You really are just finding two numbers that multiply together to give the number that's above it. So here we have 600, so I could take 600 and I could split it into, if I wanted to, 6 times 100. And then I just look and I say, okay, well 6 isn't prime because I can break 6 into 3 times 2, and if it helps you, you can put that little multiplication sign in between the two. And actually, instead of even the x, I would use the dot just in getting the habit of not using x for multiplication anymore. Just because a really common mistake that I'll see students make is, like, for example, with 6, they'll put 3 and 3 because 3 plus 3 equals 6, but we're using multiplication. Now 3 and 2 are both prime, so what I like to do is I like to circle to show that I'm at the end of a branch. I'm going to do the same thing with 100. So I might do 10 times 10, I could do 25 times 4, I could do 20 times 5, anything that I can multiply together to get to 100. Each of these 10s is going to break into 2 times 5. 2 and 5 are both prime, so I'm going to circle all those. All my branches are complete. And now, if we look at the numbers, we have 1, 2, 3 2's over here. I have 1, 2, 3 2's over here. So the prime factorization of 600 is going to be 2 times 2 times 2. And then I have a 3 over here and a 3 over here, so times 3, and then I have 2 5's here and I have 2 5's here, just showing you that they match up, times 5 times 5. Or a better way to write it using exponents is going to be 2 to the third power, because 2 is used as a factor 3 times 3 to the first power, but we don't have to write 1 in there because there's only 1 3, times 5 to the second power. And that's going to be the prime factorization of 600. Either strategy works. So just going back up here just means that we are like not done or dividing as we're going through. What I would encourage you to do right now is pause the video and try these three numbers out, and then restart the video and just check to see if your prime factorization matches up with mine. Your tree or your ladder that you use may not exactly match mine, but we're really just worried about that end part. So for me, I prefer to do prime factorization with the tree diagram. That's just because that's the one that I was most familiar with. So I'm going to take 32. I know that 32 is 4 times 8. That 4 can break into 2 times 2. 8 breaks into 2 times 4. All these 2's are prime. Notice I'm not circling the 4 because the 4 is not a prime number at the end of the branch. So 32 becomes 2 times 2 times 2 times 2 times 2, or 2 to the 5th power is the best way that you can write it. For 132, I'm going to do the same thing. I'm going to go through. So even if you got stuck and you didn't know for sure that 132 is even, so I could always just divide that by 2. Otherwise I could have used 11 and 12. 2 is prime, 66 is not, but I know that 6 times 11. 11 is prime, and then 6 is 2 times 3. So the prime factorization is going to be 2 times 2 times 3 times 11, which is also the same as 2 to the second times 3 times 11. Alright, 144, 12 times 12. Each 12 can break into 3 and 4, or if you wanted to, you could do 2 and 6. 3 is prime, so I don't have to go any further, but 4 becomes 2 times 2. 2 is prime, but 6 can break down into 2 and 3. Notice, even though I used different numbers, I still ended up with 2 2s and a 3 on each branch for my 12. So I have 2 times 2 times 2 times 2, and we always want to write them in order, usually from least to greatest. So I have 4 2s and then 2 3s, or I could write this as 2 to the 4th times 3 to the 2nd. Make sure you get this into your notes when you're all done, and then let me know if you have any questions.